Hey folks, this is Steve again. Here's another edition of Couchbase Snacks. The first attempt at Couchbase Snacks got some positive feedback, so we're trying it again. This time we're going to talk a little bit about recursion. Up here on the cafe on the sixth floor, we ended up talking a little bit about interview questions amongst folks. And of course, a popular kind of interview question is recursive algorithms. For example, Dave Finlay has an interesting question around directed acyclic graphs. Pretty cool recursive solution for that. Other folks have things like, oh, try and find a cycle in a graph. But a kind of a meta question popped up, and that was, do we actually have these kinds of recursive problems at Couchbase? And the answer is yes, we do. In fact, on something that we've been working on recently, full text indexes, has a subfeature called index aliases. Now, an index alias is kind of like a symlink or kind of like an email group in that it's basically a level of indirection. It's a name that can point to other real targets or things. For example, you might have an index, like for an employee directory, an index of all the employees. And then you say, well, let's go create an alias. For example, you might have an alias, your intranet, and it's pointed at the employee directory. So when you do a search against your intranet, you're going to get the same results as if you had searched directly against your employee directory index. And over time, you could start adding more and more stuff to your index alias. Your intranet index alias can now point at employee directory, your Jira tickets, your Git stuff, your wiki, all good. But here's where it starts to go off the rails. Let's say you got a new, I don't know, junior sysadmin that comes in on board, and he heard that, oh, everything in the intranet is in the wiki. So he goes and changes the wiki index and for whatever reason turns it into an alias. And now that wiki index alias now points at, or the way he sets it up, it's going to point at the intranet. And now you have a cycle. So now you're back to the problem of like, how do you find a cycle in a graph? And you need to do so efficiently at high performance on every single query, right? One way you could do this, of course, is you could cheat. For example, you could say, well, don't even allow users to create cycles in the first place. We're just going to detect somehow that if there are any cycles during the alias creation attempt or update attempt and reject it if there is any cycle. So nice try, but I'm going to reject your attempt to reject the attempt because that's not actually what we do. And the way the system was designed was themed a little bit more around how email groups actually work, where you could end up at runtime with cycles such as it is. Another attempt that you might have is like, well, let's go detect if there is a cycle like asynchronously or offline or lazily and cache the answer. And if there's a cycle, just don't attempt to use that thing. So our current approach, what we ended up actually doing is we don't cache. We do have a recursive implementation, here's the code, where it tries to resolve or expand the alias definitions out on every single request. And so let's go take a look at the code. Here's this fill alias function. So if you scroll down far enough, you kind of expect fill alias eventually to call itself, and yeah, and here it does that. And what it's doing is it's basically building up a list of all the leaf target indexes recursively that are part of like expanding out this alias. And the way that you might detect a cycle is if that list of target indexes actually gets too long, and that check is done here, perhaps there's a cycle. And that's how we cheated.